Homework time! Here we go again. Lesson 4, homework of Module 2, dealing with metric conversions. And we're in the second part of that module now. So let's start by putting a name atop our homework. Here's the dealio. I'll put my name, and you put yours. Good to take half a minute here, put name and date. Write your name completely. Write the date completely. I'll write today, because it is today. And you write the actual date, where and when you are. All right, let's take a look at this table, which we are to complete per the instructions. We have a smaller unit, a larger unit, and then we're asked how many times as large as. So to read this sort of as a sentence, a centimeter is a smaller unit, meter is the larger unit, and a meter is 100 times larger than a centimeter, which is also to say that a centimeter is 1/100th of a meter, just as 1 cent is 1/100th of a dollar, right? And that's exactly the logic of the second one here. Instead of being given a unit of measurement, we're giving a place value unit. So we're comparing 100 is 100 times as large as what? Well, what times 100 is 100? That's right, 1. Does that make sense? You see how this works? 1 is a smaller unit, 100 is a larger unit, and it's 100 times larger. Now when we look at this one, we're comparing the meter to the kilometer. So the meter is a smaller unit. That's, arm's length there, a little bit more than a yard, right? And then a kilometer, that's a distance. That's like we're talking about a driving distance or a biking distance, or a running distance. So the kilometer is how many times larger than the meter. Well, how many meters does it take to make a kilometer? You got it, 1,000. And now in the next one, it's same idea. We're looking at the gram. Well, 1,000 grams makes what? And you have the beauty of the metric system at work for you here. It'd be a kilogram, right? We have that prefix kilo, meaning 1,000, right? Kilogram. And now just to put it in numerical terms and place value, same idea here. Again, 1. What's 1,000 times larger than that? 1,000. You got it. Just like 1, 100 is 100 times larger than 1. There we go. 1,000 would be the larger unit. And when we look at the milliliter, that's 1,000th of what? You got it, a liter. Okay, so it's a liter, that it's 1,000th of liter, because there are 1,000 milliliters in a liter. Okay, this is all making sense. And when you look at the last one here, it's kind of jumping up the scale. We went from 100 to 1,000, now we're going all the way up. 1, well, the larger unit then is 100,000. How many times larger is 100,000 than 1? Another way of thinking of it is 1 times what is 100,000? How many ones are there in 100,000? You said it, there's 100,000. So that would be our response there. So I like this table. It makes you think a little bit about the relationships between these different units of measurement and, importantly, their relationship to place value. That's why we do all this metric stuff right after finishing up with the place value unit. So you could see how place value actually works in addition, subtraction, and now metric conversions. Beautiful. Let's roll on to number 2. And number 2, you're going to like this. It's really simple here. Don't make it harder than it needs to be. 135 is 1 blank 35 ones. 1 what? 100. Yeah. Sorry, I can't make it any more difficult for you. Yes. But this is important because you're seeing a relationship, as it just said, between place value and metric conversions. B you see is over here. So again, we have 135 broken down into 1 something and 35, but now we're talking about centimeters. So 135 centimeters is 1 meter. Okay, now you see why we're doing this. Even though it's easy in a sense, we're still learning because you're seeing, 1 is to hundredths as 1 is to meter. You're seeing the relationship between place value and the metric system. So 1,215 is 1 what and 215 ones. Well, 1 is in the, right there, in the thousands place. So it's 1,000. And when we look at the same number in terms of meters, 1,215 meters is 1 what? Now, if you're thinking centimeters, 1 centimeter is, right, about yay big. So is 1,000 meters? 1 meter is like this. So 1,000 meters, I can't do with my arms. Is that this much? No. No. So you'd catch an error there if you were to write centimeters. You'd see that's wrong. It does not make sense. 1,000 meters there is 1 kilometer. And note the funky pronunciation there, kilometer. All right, beauteous. And now we look here at 12,350 is 12 blank, 350 ones. Well, so 350 ones, we look at the 12 what? 12, what did I say? 12,000, yes. Okay, so simple, but we're learning that relationship between place value and the metric system. And so now if we think about it in terms of grams and kilograms, the 12,000 would be, in terms of grams, would be 12 kilograms. 350 grams is 350 grams. Look at that. Beautiful. Easy, but something you learn from there. So now here we're kind of working backwards. So we're saying what is 125,312 ones? Well, simply we're just taking that from unit form to standard form. We're giving it in terms of place value units, and we want to write the number in standard form as a regular old number. So 125 thousands, and notice that I end in the thousands place there, 312 ones, and I end in the ones place there. Now, thinking about the same number in terms of liters and milliliters, the question is how many milliliters is 125 liters, 312 milliliters? Well, 125 liters would be 125,000 milliliters. You got it. So it's the same thing, isn't it? 125,000 milliliters, right? And then we also have 312 milliliters. Yes, I'm writing the same answer I did in the last one. So you see the relationship, 125 liters, 125 thousands. 312 ones, 312 milliliters. Beauteous. 2 and 3. Bang, bang. On to number 4. All right, and in number 4, we're going to use that conversion knowledge, the relationship metric system to place value, to do some simple comparisons here. So starting off, we're to fill in each with greater than, less than, or equal to. First number we're given, we're comparing 890,353 milliliters, comparing that with 89 liters, 353 milliliters. And you notice a similarity between the numbers here, so you might be tending to think like, well, first rough guess, maybe these are equal. I'm looking at the same digits here. So let's take a closer look though. Now we could do this one of two ways. We could take the mixed units here and make it all milliliters, make it all the smaller unit, or we could take the smaller unit and make it mixed units to make it easier to do a direct comparison. Let's take the smaller unit, the milliliters here, and put that into liters and milliliters, into mixed units. So when I look at this 890,000, I know that that's a certain number of liters, and I know that 1 liter is 1,000 milliliters. So 890,000 milliliters is 890 liters. There we go. Okay, so we see that place value connection, 890 liters, that's a capital L. And the 353 milliliters is just that, 353 milliliters. Now I can easily make a comparison and see 890 liters compared to 89 liters. Oh, it's far more, right? How much more? Yes, 10 times more, isn't it? So that first number here is greater than the second number. And that's how you read these like a sentence, say straight through. This number is greater than that number. And this is our greater than sign. Second one, similar idea, but here we're dealing with meters and kilometers. And again, the digits look similar, so you might tend towards a rough guess of, well, these could be equal. Well, let's see. 2 kilometers, 13 meters, compared to 2,103 meters. Well, let's do this one the other way. Let's put the mixed units into the smaller unit. So 2 kilometers, well, 1 kilometer is 1,000 meters. We know that relationship. So 2 kilometers would be, yes, 2,000 meters. But of course we have these 13 meters as well to incorporate in this single count of meters. And you could write this out in 2 steps. You could write 2,000 meters plus 13 meters. And that would show it to you that we have no hundreds, right? So there's a 0 in the hundreds place. We have a value of 0 there. And then the 13 meters. And now when you go to compare, it's quite apparent, isn't it? 2,013 meters compared to 2,103 meters. Ah, this is clearly less. 13 is less than 103. So this number is less than, yes, less than that number. Great, now we're going to take everything we've done so far and put it to use in this word problem here with Brandon's backpack. So Brandon's backpack weighs 3,140 grams. All right, it's the weight of the backpack. Brandon, we're talking about Brandon himself, the boy Brandon, weighs 22 kilograms, 610 grams more than his backpack. So if Brandon stands on the scale wearing his backpack, what will the weight read? Okay, so are we doing a comparison here? Are we saying this is so much more than that or so much less than? Oh, we are, aren't we? And that means, what did we learn? We need to draw 2 tapes. Okay, so for backpack, because his name is Brandon, I'm going to put P for backpack. And there we know the actual weight. I'll draw my nice little tape here for the pack. And what's the weight of the backpack? It is 3,140 grams. Now Brandon, the feller, he weighs 22 kilograms, 610 grams more than the backpack. So it's going to be the backpack and then 22 and change kilograms more. So really, I should make this line like super long, but I'm going to stop there because of space constraints. It doesn't have to be perfectly proportional. We get the idea that Brandon weighs more than a backpack. Now the key is this whole tape 22 kilograms, 610 grams? Say no. The answer is no. No. That weight refers to the difference between them. That is this right here. That is 22 kilograms, 610 grams. Now, it would be one thing if they're simply asking us what is Brandon's weight, right? That's something we could calculate given what we have. In fact, I could even add in, if you like, a little dotted line there. It makes it clear that we're comparing the backpack and how much more Brandon himself weighs. But what is the question asking us? It says if he stands on the scale wearing the backpack. So we're looking for Brandon and backpack together. We're looking for a total here. So that is our unknown. We'll call that W for weight. Now we see what we need to do. First we have to calculate the full value of B, Brandon's weight, right? Because we just know how much more he weighs in his backpack, and then put the two of them together to get the grand total. So to calculate Brandon's weight, we're adding kilograms and grams to grams. So it makes sense in this case to put them into the same, either both in the smaller unit or both in mixed units. Let's put them both in the smaller units. I think that's easy. 22 kilograms is 22, how many grams? 22,000 grams. All right, so you see why I want to do it that way. 22,000, and we have, don't forget, 610 grams. We're adding that to the weight of the backpack, which is 3,140 grams. And this, remember, is not to give us a final answer. This is just to give us Brandon's weight, because we know how much more he weighs than his backpack. So 0 and 0 make 0. 1 and 4 make 5. 6 plus 1, 7. 2 plus 3, 5. Drop that comma. And 2 we're adding nothing to, so that's 2. And we're talking about grams. So now we have Brandon's weight. So I'm going to actually write here B equals. So I remember that's Brandon's weight. Now to get Brandon with the backpack, yes, we simply add the Brandon weight we just calculated to the pack weight, and we will have a grand total here, our W that we're trying to solve for. So I take Brandon's weight that we just calculated, the 25,750 grams, add it to the weight of the backpack, 3,140 grams, and then I will get a total for the Brandon plus pack together. Nice easy addition they're throwing us here, huh? No regrouping at all. 0 and 0 make 0. 5 and 4, 9, good. 7 plus 1, 8. 5 and 3, also 8, drop that comma. 2, we're adding nothing to. And we can see, and it's grams, we can see by a quick estimate, just by looking at the largest place here, 22 plus 3 is 25, plus 3 again is 28. Oh, and we got 28,000. Okay, so that works. Now we just simply need a statement. Brandon and his backpack together. And there's many ways you can write this. I mean, you could answer the question using the phrasing of the question, saying, if Brandon stays on the scale wearing his backpack, the weight will read bloom. But I'm doing it this way. Brandon and his backpack together weigh. Now, I'm going to write it both ways because we were given it, the weights we were given both mixed units and we were given all in the smaller units. So I'm going to do both. 28,890 grams, comma, or, now what would that be in mixed units? Well, the 28,000, when we're talking about grams, 28,000 grams would be 28 kilograms. Good, you've got this now. 28 kilograms, and don't forget we have, what do we have here? 890 grams. Beauteous. What? Oh, beautiful. All right, let's roll on to number 6. All right, and now we're finishing out homework time. Number 6 and 7, we're given a number line, and we have 1, 2, 3, 4, or 1, 2, 3, 4, 5 measurements to place on that number line. And I tell you, based on my experience teaching 4th grade Eureka Math, this is harder than it looks. So be patient here. Be patient. This might take a little while, but if you can do this, notice we're on lesson 4 out of 5 lessons. We're almost done with module 2 here. If you can do this, then you can do anything. You got it. So if this seems a little difficult, that's okay. Soldier through it, and you will have this mastered. Let's dive in. When we look at the number line, it goes from 3,000 meters to 4,000 meters. And you notice they've marked off each quarter of the way along here: 3,250 meters, 3,500 meters, 3,750 meters, up to 4,000. And when we look at our measurements, only one of them is actually in that format, isn't it? In fact, let's just go ahead and place that, because we see 3,500 meters is what? That's already a mark on our line. So I'm going to put the ones I'm placing, I'm going to write them on the bottom. So that's 3,500 meters. Boy, they gave us a softball there. That one's done. Now with the other ones, we need to put them into terms of meters, just meters, so that we can effectively place them. So let's start with this one. 3 kilometers, 275 meters. Well, 3 kilometers, we want to put this all into meters. 3 kilometers is how many meters? 1 kilometer is 1,000 meters. 2 kilometers is 2,000 meters. 3 kilometers is, got it, 3,000 meters. And don't forget, we have 275 meters besides. So, where would that fall here? 3,000, 3,250, 3,500. Okay, well, I can see here, if I look at this, I mean, I could think there's 250, so 3,300, 3,400, 3,500. I can see that it's going to come shortly after 3,250 meters. So I'm going to place my line for that one right about here. And I'm going to write it in the format that it was given to me. I could write it either way, but I'm going to write it as 3 kilometers, 275 meters. You see how 3,250, 260, 270, 275, be right there. Now let's look over, so done with that one. 3 kilometers, 5 meters. All right, no problem. We already know that 3 kilometers is what? 3,000 meters. We just did that. So 3,000, we want to put this all into meters, and then we have 5 meters. So think of it as 3,000 meters plus 5 meters would be 3,005. A mistake here would be to write 3, 5, or even 3,500. It's not 500, it's 5. There are 0 hundreds, there are 0 tens, and then we have the 5 meters. So, and this is all meters, where would 3,005 go? Now look at this, 3,000, 3,250, 3,005 is just past that line here, right? So, put a marker there, and I'll write it in the form that it was given to me. 3 kilometers, 5 meters. All right, we see how this works, and that's done. Now we're given a number in centimeters. Oh boy. Now this is a little tricky, right? Because our conversion factor is different here, because it's no longer 1,000 like we were dealing with those kilometers. When we're going from the centimeters to meters, our conversion factor is 100, because when you think about that meter stick, how many centimeters in there? 100. Okay, so we could do this. So one way to think of this is to look at the hundreds place right there, that number. How many hundreds are there? And we did this back in place value, especially we did this in the warm-ups on like the end of Module 1, lesson 17, 18, 19. How many hundreds in this number will tell us how many meters there are? Read it up to the hundreds place. 3,940. 3,940 hundreds. So that tells you how many meters there are. There are 3,940 meters. And notice I don't have to do like any fancy multiplication, division, formulas. I just think about it in terms of place value. 3,940 meters. Oh, well, that works. So where would I place that here? Well, I have 3,750. That's less than that. And then I have 4,000 is, ooh, just above that, right? So 3,940 would be way up here. And I'll write it in the form that it was given to me, 394,000 centimeters. That last one was a little tricky, wasn't it? So if that makes your brain hurt a little, what you can do is draw out a place value chart and then basically divide by 100. And so if you divide by 10 and divide by 10 again, that 394,000 becomes 39,400, and divide by 10 again, so you're dividing by 100 altogether, you get 3,940 meters. All right, now let's do the same thing in number 7. We see our scale here goes from 0 grams to 4,000 grams. So we have a pretty big spread there. And let's look at our measurements. Are any of them in that, hey, here's straight grams form? Ah, yes, look, 3 of them. Oh, mercy me. So I think to help us here, we have to look at these unlabeled pegs here, though, on the line to know what we're talking about. So it goes 0, blank, 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 4. What's the pattern? What would this one be? What's this marker? What's this marker that we're given unlabeled? Yes, you can see it, right? 1, 2, 3, 4, right? So this would be 1,000 grams. Let's go ahead and label these markers. 1,000 grams. This would be 2,000 grams. And this one here would be 3,000 grams. Notice the instructions don't say to do that, but if you didn't, you'd probably end up a little confuselated. All right, so let's do the easy ones first. 3,079 grams. Okay. Well, I can see, look, this is 3,000 to 4,000. So my midpoint, I'm actually going to draw in the midpoint here. So that is 3,500. Remember we learned this in rounding? Grams would be my midpoint. Where would 3,079 grams fall? Oh, nice and close to 3,000 grams, right? Because it's just over it. It's not even up to 100, 3,100. So 3,079 grams. And now so that's what that one, let's cross it out. All right, now we have 3,579 grams. Similar, but we have that 500. Ah, well, good thing I marked that midpoint. That makes it easier, doesn't it? There's 3,500, so 3,579 would, yes, indeed, come right after it. So 3,579 grams. You see, if you just think about this logically, it's not so difficult. It's a little bit of a mind bender at times. And then I'm given those same digits, the 579, but 579 grams. Oh, well, does that fall between 3 and 4,000? No. Between 2 and 3,000? No. Between 1 and 2,000? No. It falls between 0 and 1,000. So here let me as well go ahead and mark my midpoint, which will help me to place it. What comes between 0 and 1,000 grams? Again, same thing we did finding the midpoint and rounding. It's 500 is half of 1,000. So now placing 579 grams is quite simple. We see it comes right after 500 grams. 579 grams. Lovely. That one's done. All right, now we have these two that are given to us in mixed units, which we will convert all into grams so as to more easily and accurately place them. So we have 1 kilogram, 379 grams. Well, we know that 1 kilogram is 1,000 grams, correct? So 1 kilogram is 1,000 grams with the 379 grams, 1,379 grams. Can we place that? Well, we can see it falls between 1,000 and 2,000 grams. I'll again go ahead and mark my midpoint here. What's my midpoint between 1,000 and 2,000? Yep, you're good at knowing the midpoint from all that work we did before, and now you see why we did it. It'll be 1,500 grams. So 1,379 grams? Yes, it would fall, kind of roundabouts here. Closer to 500 than to 1,000, right? And I'll write it in the form which it was given to me, 1 kilogram, 379 grams. Lovely. Cross it out. All right, now I have 2 kilograms, 79 grams. All right, well, let me put that all in grams because that's what my scale is in instead of in mixed units. So 2 kilograms, well, again, 1 kilogram is 1,000 grams. 2 kilograms is 2,000 grams. Very good. So 2,000, and then I have this 79. A little thinking required here. Do I write 2 comma 79? No, that's not even a legitimate number. We have no hundreds of grams, so we place a 0 there, and then 79 grams. And again, if it helps you think of it this way, think of it as 2,000 plus 79. You could even set it up as vertical addition. So now I'll go ahead and place the midpoint here. I know it falls between 2,000 and 3,000 grams. My midpoint would be 2,500 grams. Now 2,079, oh, that's going to be right close to the 2,000 side of things, right? Between 2,000 and 2,500, more on this end. And I'll write it in the form which it was given to me, 2 kilograms, 79 grams. And now you see, even things that are a little tricky, if you take your time and really think it through, you can get it all right. And beautiful. Look what happened. Homework time is through. Excellent. Great work. I will see you next time. It is again homework time.